All right, so this is part 2 of solving trig equations. They keep on getting a little bit more and more challenging. This one starts off where it kind of has a quadratic feel to it. So if it helps, then let's not treat them as trig functions. Let's treat it as a quadratic. So that's x squared plus 2x plus 1. And you can factor that. So I could factor this into an x, so what multiplies to 1 that adds to 2? 1 and 1. So the difference is, we're just looking at cosine x plus 1 times another cosine x plus 1. So that's the only difference. So if that helps you, some people can see it, some people can't. So if you need to rewrite this as something that's a little bit easier to see, then just rewrite it as kind of a regular algebra quadratic, factor it, and then pull your sines, cosines, whatever your trig function is. So what we always do with our factors is we set our factors equal to 0. Now that's going to get us the exact same answer as whatever this is about to get us, so I'm just going to do the 1. And we have cosine x, so we'll subtract 1. So cosine x is going to equal a negative 1. And cosine of what angle is going to equal a negative 1? Well, if we go back to our picture, cosine is an x value, so we're looking at pi being our angle measurement. So our answer is pi. And it's twice, actually. So we'd also get another pi out of that. So that means that if you were to graph this thing, you can definitely check all of your work and check your answers, is graph this graph from 0 to 2 pi, and you'll see, just like before, solutions are x-intercepts. So you're going to see an x-intercept, and most likely, because it's a repeat, there's a good chance you're going to see a multiplicity, and so you're going to see a bounce kind of a thing, because it's a multiplicity of 2. So I don't know what the graph looks like, but whatever the graph is at pi, it's going to bounce. So whether it's kind of bouncing from above or bouncing from below, I don't really know. So let's do another one. All right, we got ourselves a tangent theta minus cotangent theta equal to 0. So when is tangent theta minus cotangent theta equal to 0? Well, I'm sure there's other ways to do this one, but what kind of came into my head was the fact that you got a tangent minus a cotangent. If I don't really know where to go, I rewrite things as sines and cosines. So sine over cosine minus cosine over sine equaling 0. So in order to make this happen, we need common denominators. So our common denominator on this is going to be cosine sine. So we'll multiply sine here, we'll multiply cosine here. All right, so that gets us, actually that gives us a different route. Already rethinking my route. So let me do that again. So instead, let's bump this over. It might be a little bit of a quicker route rather than getting common denominators and all that stuff. So if I put the cotangent over here, this is still sine over cosine. And I was thinking more trig identities rather than solving. Because trig identities, you really can't move things around, but on solving you can. So if we move another piece over, that's totally fine. And the reason I like this is because you can just cross multiply. So this cross product is sine squared, and this equals this cross product, which is cosine squared. And then let's pull everything over to one side. Sine squared theta minus cosine squared theta is equal to 0. And then from here, we can, I guess it really doesn't matter, we can, really the best, you have to put this all together into one common trig function. So we're looking at either you make everything into sines or you make everything into cosines, and it doesn't matter, you just got to pick one and go with it. So let's take this piece and let's replace it with 1 minus sine squared theta, because that is a trig identity that cosine squared is equal to 1 minus sine squared. Distribute our negative, so then that's going to get us a sine 2 sine squared, and then minus 1 equals 0. So we would add 1, divide by 2. Sine squared theta is 1 over 2. All right, so now, finally, a little bit of manipulation. We're able to get something that we can kind of work with a little nicer. We're going to square root. So we're looking at sine of theta is equal to plus or minus. Square root of 1 is 1. Square root of 2, I am not going to bother rationalizing because this automatically shows me, if I rationalize it, it's not as obvious. If I leave it like this, it screams 45-degree angle. So sine of 45 is 1 over root 2, and because of the plus or minus, we want every single 45-degree reference angle. So theta is going to be pi over 4, 3 pi over 4. Those would be our positives. 5 pi over 4, and 7 pi over 4. And those are going to be our negatives. All right, so definitely some are a little rougher than others. Let's do one more. So we'll do number 6 here is going to be cosecant squared theta minus 2 cotangent theta equal to 0. Again, not helpful like up here where you got two different trig values going on. There's really not much I can do with cotangent, but cosecant squared I can definitely do something with. And from previous videos I had a big chunk of the trig identities, so I feel like cosecant squared is something. It's right there, so 1 plus cotangent squared is what I can replace that with. So let me do that. So 1 plus cotangent squared. And then minus 2 cotangent theta equals 0. Okay, so this has a quadratic feel, so I'm going to rewrite it like a quadratic. Minus 2 cotangent theta plus 1 equals 0. So this is like an x squared minus a 2x plus 1. So if it helps, x squared minus 2x plus 1. If I factor that, I have a, let's see, x minus 1. X minus 1. So we're looking at cotangent of theta minus 1 squared equal to 0. So we could square root both sides. It would basically just drop it out. We're going to get the exact same result twice. So it's like a multiplicity kind of a thing again here. So cotangent theta minus 1 is equal to 0. We add 1 over. Cotangent theta equals 1. I think of that more as a tangent of theta. So I do the reciprocal of that, which is the reciprocal of this. Reciprocal of that is still just a 1. So tangent of what angle is going to get you a 1? You're looking at a 45 because you're doing opposite over adjacent, but you're looking for a 45 in the positive. So you want a pi over 4 and then a 1, 2, 3, 4, 5 pi over 4. So theta is going to be pi over 4 and 5 pi over 4. Okay, definitely those are a little rougher. All right, and then we have one more that has kind of another level of it. So that was solving equations, part 2.